Okay, Physics 11H, quiz solutions. All right, so you guys did well on this. A couple mistakes. I messed up the quiz. One of the questions in the auto grading thing, so if you go back and look at it, go by what the video says, not by what it says. I went back and corrected all the ones that were wrong. But let's just get through this pretty quick here. So what is the magnitude of the velocity? Now, your order might have been different than what's going on here. But what is the magnitude of the velocity of a 25 kilogram object that has a momentum of 100 kilogram times meters per second? So the momentum is 100 kilogram times meters per second. The velocity is unknown. The mass is 25 kilograms. All right, so P equals mv, or V would be P over m, momentum over the mass. So 100 divided by 25 is 4 meters per second. Everybody got that one right. Very good job. Okay? 4 meters per second. Next one, a 1.18 kilogram car traveling at 0.8 meters per second to the right. So let me just draw a little picture here to keep this organized. So we've got mass is 0.18 kilograms, traveling to the right at, the right is positive, 0.80 meters per second. Collides with a 0.1 kilogram car initially at rest. Mass equals 0.10 kilograms initially at rest. The cars locked together upon collision. The final velocity of the car is what after the collision. So they lock together and slide away, so their new combined mass is 0.28 kilograms, and we're looking for the velocity that they slide away with. Now, on my one I made on scrap paper before I uploaded it, I changed one of these values, so it wasn't exactly like the one in the review book, but I forgot to change it when I typed it. So anyway, I put in the wrong answer, I think, for this one, didn't I? So most of you got this one right, but let's go through here. So P, momentum before the collision, must equal the total momentum after. That's the equation that's on the reference table, although I guess we're not going to need it. You guys don't have to take the Regents. As long as you pass the course, you'll get credit for it, which is probably a very good thing because we have quite a few students. We have one student came in from out of state, hadn't taken the Regencies, so that might be a good thing. That might work out well for Sonia. So anyway, P before equals P after. Total momentum before, 0.18 kilograms times positive 0.80 meters per second. And this one's momentum is 0 equals momentum afterwards, which is 0.28 kilograms times the unknown velocity. So the total momentum is in this cart. So now we just have to solve for the velocity. So velocity is equal to 0.18. Let me get out my calculator here. 0.18 times 0.8. All right. And then 0.144 divided by 0.28 equals 0.51 meters per second. And the answer comes out positive, so this slides off in the positive direction. All right. So 0.51 meters per second is the answer. 73% of you got that right. All right, so the next one. A 2,400 kilogram cart is traveling at a speed of 20 meters per second. Compared to the magnitude of the force required to stop the car in 12 seconds, the magnitude of the force required to stop the car in 6 seconds is, well, force times time equals impulse, which equals mass times change in velocity. All right? Force times time equals mass times change in velocity. Impulse equals change in momentum. Well, the change in momentum is going to be the same no matter what. It's because it's going to be a 2,400 kilogram car changing by a speed of negative 20 meters per second. You got to take away all that velocity, right? So no matter what, however fast you do it, it's going to still have to be a change of momentum of 4,800 kilograms times meters per second, force times time. So if you make the time shorter, it's going to take more force, right? Because if you're trying to slow down something quicker, it takes more force. Force times time because m delta v. This is just Newton's second law. So what you know conceptually about Newton's second law applies to this problem. So if you know something's, you want to accelerate something more, which is slowing it down or changing its velocity quicker, it takes more force. So it's got to take more force. So it's got to be either twice as great or 4 times as great. Now the answer is twice as great, right? If you cut the time in half, then the force you'll have to double so that it's a wash, okay? So it's twice as great, the force. Cut the time in half, double the force, still the same. You could plug in a number here too, right? You could plug in time for 12 seconds, calculate the amount of force needed, and then put in time of 6, calculate the force needed, and see that it's double the force. Number 4, compared to a 3 kilogram object moving at 4 meters per second, a 4 kilogram object moving at 3 meters per second has, oh man, nobody fell for the wrong, well, one person fell for the wrong answer. So this is the inertia question. Now, I'll probably lay off this question now because we're not taking the regions. I always put it out there, keep putting it out there because it does show up on the regions every year. But, you know, that ship has sailed. So anyway, they would actually have the same momentum, these two objects. Because remember, momentum equals mass times velocity. So we have 3 times 4 and 4 times 3. They both have a momentum of 12, right? But that's not one of the choices. So I was hoping to catch people on same inertia, thinking that you'd think this is inertia, but it's not. So the answer is more inertia. More inertia. The 4 kilogram object has more mass, so therefore it has more inertia. And 18 of you got that correct, so that's good. 94%. A 10 Newton force to the east acts on an object for 0.1 seconds. All right, so we've got some object. It acts to the east. North, south, west, east. Okay, so it's acting this way. So it's a 10 Newton force acting to the east for a time of 0.010 seconds. What force acting on the object for 0.020 seconds would produce the same impulse? All right, so this would be an impulse of 10 times 0.01, right? Just sanity check. Let's just type it in our calculator so we don't mess it up. 10 times 0.01. Oh, look at that. 0.1. Right? 10 times that. So you just move it over. So the impulse here would be 0.1 Newton seconds. All right. So it's asking us if it acted on it, if it doubled the amount of time we acted on it, all right, but we wanted to produce the same impulse, we'd have to cut the force in half, right? Again, force times time equals impulse. So if you are doubling the time, you'd have to cut the force in half. So it'd have to go down to 5 newtons. 94% of you, only one person missed this question. So that's good. On this whole thing, there are only a couple questions missed, not a whole lot of wrong answers. The worst one was those couple early ones, 73% of you. But good job overall on the quiz. We're going to keep rolling with the quizzes. Have a good week, everybody. We'll see you later.